What up, people? We're back. Another day is here for this AI in production conference. Whew. This here is our first keynote of the day. And goodness, what a keynote we've got. I'm gonna call Philipp to the stage. Where you at, Philipp? How you doing, dude?
Hi, I'm good. I'm in Germany. It's already like close to 6, so super happy to be here. Super excited to be like the first starting of the day. So
There we
yeah,
go,
I
dude.
hope everyone is ready.
Kick it off strong. Well, I know you got all kinds of stuff planned for us, and I am a fan who's been following your work for a while. You're doing incredible stuff on all the socials and just about all different conferences. So I'm gonna let you do your thing. I'll be back in like 20-25 minutes, and all the questions that come through in the chat, I'll make sure to ask them. So if anyone has questions, drop them in the chat. Again, for those people that are interested in introducing themselves and connecting with others on LinkedIn, we've got a whole channel for it. Click the channel. You don't need to put it into the chat. Philipp, man, I see you sharing your screen already. I'm gonna hand it right over to you and let you kick us off.
Thanks. So perfect. Okay, screen is already there. So yeah, welcome from research to production, fine-tuning LLMs and aligning LLMs. So who am I? I'm Philipp. I'm, as mentioned, based in Germany. I'm currently tech lead at Hugging Face, where I lead our partnership with AWS, Azure, or now since recent Google Cloud. So if you are doing anything with Hugging Face on any cloud and it's not working, please ping me and say, yeah, Philipp, it's not working. It's your fault. My motivation is like really to teach you how to like fine-tune LLMs, open LLMs, how you can use it for production use cases. I started with BERT in 2018, which is, I guess, now very boring, and are now very focused on reinforcement learning from human feedback and LLMs. And I truly believe that only through open source we can use generative AI responsibly and make sure that we are not creating too much harm. And before we go into like the details, I want to quickly highlight something which I think has changed over the last 2 years, that generative AI is now in everyday life. We have ChatGPT, we have Snapchat or like Stability AI generating images. We have GitHub Copilot and Code Whisperer helping us write faster and more and better code. We have telecommunication companies now creating LLMs for customer support and many more. So generative AI is already everywhere. And what is very interesting is like generative AI is also helping us to be more productive. And that's a great case study from like the Boston Consulting Group, who more or less tested how well are my consultants doing when I provide them access to ChatGPT. And they evaluated 18 realistic tasks for them. And they compared consultants with AI and consultants without AI. And consultants with AI were able to finish 12% more tasks, were 25% faster, and also generated 40% higher quality. So using generative AI and LLMs, if they are correctly fine-tuned, will help us be more productive in almost like any task. And to quickly look back on what's the difference between a generative task and an extractive task. So extractive is what we might know from like the previous year and like traditional machine learning algorithm, where we are trying to extract some kind of information. So if we have, for example, our sentence here with my name is Sarah and I live in London, I can try to extract the entities with Sarah being a person or London is a location. Another example would be, okay, can we classify the sentence to give it some kind of sentiment? Is it positive? Is it negative? And on the other side, generative tasks are really involving creating new data. It could be text, it could be image. We already heard earlier that we can now generate super cool songs from text and input. So generative AI is all about creating something new, and extractive tasks is more about, okay, what can I do with my task? Can I like cluster it, classify it? And before we go really into like how this works, we maybe should look at how do LLMs even learn. So LLMs are mostly referring to decoder type transformer models. So BERT was an encoder, and LLMs are mostly decoder, which are learning different. And like in super simple words, LLMs are more or less just some dumb computers trying to complete a sentence and predicting the next word. So if my current position or input in my text field is the LLM tries to find, okay, what's the next most probable token or word could be my name is, and then it goes on, and Philip, and then we have my name is Philip, and it's really this loop where we have our like current input and then trying to predict the next input. So if you chat with ChatGPT, it's not like one prediction the model does. It's really, okay, I have all of the input before, what's the next most likely token? And then, okay, I have all of this, okay, what's the next most likely token? And that's how the LLM predicts or generates its text. And what's super exciting for me, and especially at Hugging Face and the open source community, open is really an alternative to closed source generative AI and LLM. So if we think back 1 year ago, I think GPT-4 was roughly announced. ChatGPT was announced November 2022. So closed source was really dominant, was really pushing, and we were all like, okay, wow, that's incredible. That's impossible to create with current open models. But then we really in 2023 had the rise of open LLM starting in February with Llama from Meta AI, which more or less released overnight an LLM which was as performant as GPT-3. And then like a few days after, Alpaca, which was a research project from the Stanford University, came out, which used the first original Llama with some synthetic generated data from GPT-3 and created Alpaca, which was now a model which could follow instructions from inputs. And then all of this, we generated Vicuna and Koala, which were similar Llama-tuned model. In May, we got StarCoder and StarChat, which were popular coding model. We got Falcon, and then in July, we got Llama 2, which is still one of the best open models we have. Then Mistral AI came out of nowhere with Mistral 7B in September. And like, it really looks like, okay, open is not really stopping, and we are closing the gap and catching up. And that's true. So the LMSys Chatbot Arena is a leaderboard where you can chat for free with multiple LLMs and can rate the responses. And in there, we have closed source models with GPT-4 or Claude, but also open models with Mixtral or Llama or E or other models. And then the users more or less give the responses a rating. So it's really feedback and community driven. And in this leaderboard, Mixtral, which is the latest model from Mistral AI, performs equally well as GPT 3.5 Turbo. So we really catched up on, like, not on the most biggest model, but on very capable closed source models with GPT 3.5, and now have open alternatives, which I can almost run on my M2 Mac. So it's super, super fantastic. But of course, with those open models, we need to adjust them and need to make sure that we can like fine tune them to our own needs, to my own data, and to my use case. But maybe before we go in there, one last slide on which is super important is that open source might be lagging behind, but we are keeping the pace. That's a chart an old colleague, Julian Leno, created from Hugging Face, where really we compared, okay, how much compute and time was invested into closed source models and where we are in open source. And there we can definitely see with the yellow line and like the green bluish kind of line is that open source is keeping the pace. So we had GPT-4 in February 2023. And with this assumption, we most likely will have a GPT-4 like performing model by the summer of this year, which is super exciting for everyone, I guess, since we can then fine tune the models. And when training or fine-tuning models, we typically have 3 different stages. The first stage is the pre-training stage. Then we have fine-tuning and alignment. And today we are only going to focus on fine-tuning and alignment. And during pre-training, which is also the most cost-effective stage, you more or less use the algorithm we have seen in the beginning, where we are trying to predict new tokens. And this algorithm is used to learn about the world using trillions of different tokens and more or less the whole internet. And for this, we need a lot of compute. So I think GPT-4 costed around, or it's estimated costed around $100 million to train. And $100 million is not coming from nothing. You need hundreds or thousands of different GPUs, and it takes super, super long. So that's very cool to see that companies like Meta, Mistral, or since yesterday, Google, are releasing those open models, which we can, as like community or individual, take and fine tune them. And fine tuning is way more accessible than pre-training, since we only need one GPU, it costs way less, we need way less data, and we can really use it for adjusting the model to our own tasks. So what we are going to do with fine-tuning is that we use still the same algorithm. So we are still trying to predict the next token, but what's different to pre-training is that we now have data sets which are not like just a web page where we are trying to complete a text. We really have those instructions where we have an input and an expected output. So on the right side here, I provided an example for like a typical like more story writing task is, okay, the prompt, our input could be write a short story about Boston, and then the output would be a story about Boston with the spirit of revolution. And what we are going to do during fine-tuning is that we have those like input and outputs. And what we are really trying to do is like try to minimize the difference between what the model generates and the output. So we are trying to teach the model to get as close as to the original ground truth as we have provided in our data set. But what's really challenging with fine-tuning, especially on generative AI, compared to what we might know from like typical classification tasks, that it's way harder to evaluate, since as you can see on the right side, we have a whole text, right? So it's not only a class. We don't have, okay, the weather is nice, okay, we can classify it in like sentiment positive, and then we can create labels and score them and get an accuracy. And that's way more challenging with generative AI, since, okay, we get a story about Boston, but is it a good story? What does a good story for me personally mean? Maybe I'm the type of guy who prefers like bullet points instead of like written text. So evaluating generative models is way harder and like super subjective to like personal needs, or maybe what you're trying to optimize for. What are really the benefits here? Mentioned already, it's super cheap, especially with techniques like parameter efficient fine-tuning, which reduces the memory needed for training even more. We can like train an LLM like Llama or Mistral for only like $10 or so. And what's also cool, we don't need millions and trillions of different data samples. We can fine tune a model already with like a few thousand samples. And what is even cooler is that we can now use those pretty strong LLMs to generate synthetic data. So generate those examples for us from like maybe a text I provide about my environment or about my company, or like some kind of FAQ, which I then use to fine tune the model to answer for my needs. So we are already talking about instruction data sets, and what makes a good instruction data set is as critical as it could be. So if we have bad data, our model will be dead. So it's like the same story as we had for traditional machine learning, garbage in, garbage out. So we really need to make sure we have good instructions or instruction data set. And those mostly consist out of, okay, we really need clear instructions. So we should be very specific on, okay, what should the model do? You might already experience this when chatting with ChatGPT, that if you are not super specific and clear on what the model should do, it might generate something which is not what you want. So we need clear and specific instruction. We need a diverse set of topics and tasks. So for example, if you have a data set of 10,000 instructions and 9,000 of them are about writing stories about Boston and different companies, like locations and cities. And then if you want to use the model to do math or question answering, it might not perform as well, since the majority of the data set was about content writing. We need definitely consistent formatting. So this means all of our instructions should be like structured the same. An example could be the alpaca format, where we have similar to markdowns, like some hashtags, and then like the instruction with our text. And then the response is also like similar structured with like those hashtags and then the response. And still human feedback is super critical. If we go back to our story about Boston, is okay, maybe we have a story about Boston, but the better the story, or like the more like differentiated the story is, the better we can like tune our model. So if we want to create a question answering system, and the answer should not only be the answer, maybe if we want an answer which acknowledge the questions, add some more detailed information, we can help tune the model to like listen to our needs by having like good data. An example for a good instruction data set is Alpaca, which is also the name of the fine-tuned model from Stanford. And what Stanford did here is basically use Text DaVinci 3, so the original GPT-3 model, and use the method called self-instruct to generate instruction data. So they used an LLM based on like 175 instruction seed data to generate 50,000 different instruction following examples with like brainstorm creative ideas for designing a conference room, and then with an appropriate output. More advanced method to Alpaca, or like the synthetic approach, is WizardLM, or the method is Evil Instruct, where you more or less try to involve and make instructions more complicated, where you start with a seed instruction, which could be, I hope you can see it, is like the initial instruction would be 1 + 1. And then one method from Evil Instruct is deepening, which could then turn into the output, okay, in what situation does 1 + 1 not equal 2? And those different prompts are then used against a good LLM, and the good LLM, or like the already strong big LLM, generates a response, and then we have new prompt and response pairs we can then use to fine-tune smaller models. And what's really cool about those instruction or synthetic methods is that you can apply them to your own domain or to your own like context. So if you work in a medical domain, if you work in like a healthcare domain, or like pharmacy or agriculture, you can more or less use a set of initial seed prompts and an already existing LLM like Mistral, Mixtral, or GPT-4, provide your unstructured web text or like domain-specific text with the Evil Instruct method, and create those different seed prompts, and then like try to create more complex prompts for your domain. And then you end up with like a huge set of instructions for your domain, which you can then fine-tune your model, which can be then generalized to like new contexts and new use cases in the same domain. And how can you do all of that, or how can I train my model? So at Hugging Face, we have, I'm pretty sure not every one of you have heard about it, but TRL is a pretty new library to make it super easy for you to fine-tune for instruction following, and also later for alignment, where we provide trainers. So from transformers, we have the trainer, which makes it super easy to train transformers in general. And TRL, we have generative AI trainers with like SFT, which stands for Supervised Fine-Tuning, which you can use to easily fine-tune models for instruction following. And all you need to do is create your data set as a JSON, for example, where you have a prompt and a completion, and then you can use the SFT trainer, and the trainer abstracts all of the heavy lifting away from you. So it takes care of like, okay, how do I format it correctly? How do I tokenize it? How do I like select the right batch size? What's super cool about the SFT trainer, it directly supports path. So if I want to use parameter efficient fine-tuning with LoRa or QLoRa to save more memory, I only need to provide a config. And for this, we created, first of all, examples in the TRL documentation, and I wrote a nice blog post, I think early January, about how to fine-tune LLMs in 2024. It's really an end-to-end walkthrough, starting from, okay, I have a use case. Does the use case even make sense for fine-tuning? And then what steps do I need to create and train the model? So if you are interested in fine-tuning your model, definitely check it out. And what do we want to do after fine-tuning? So normally fine-tuning might be enough for like 80-90% of your use cases. You can get started, you can create a proof of concept, you can collect feedback from your users to improve your data set, to improve your model, and then iterate on it. And what we now see in like the research, or also in the closed source domain, is that after we have our model, which can generate instructions for responses to our instructions, we want to align it. And aligning could have like different meaning. For example, ChatGPT or like Gemini, mostly aligning is to prevent outputs to be harmful. So you probably have heard about, as an AI or as a language model, I cannot blah, 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 and so on. And this is achieved by using alignment technique with RLHF, but alignment can also be used to improve the outputs. And what I mean by this is we can like look at a practical example. So I found this Stack Overflow questions where someone asked, okay, is it possible to train a model by XGBoost that has multiple continuous outputs, multi-regression? What would be the objective of training such a model? And for this, we got 6 submitted answers. And I collected 2 of them. So we have one. The left one is a text output with you can use linear regression, random forest regressor, and so on to achieve your training. And the right one is my suggestion is to use, and then we have like a link to a documentation as a wrapper, and then also a code snippet. And what we see here is really what goes down to like the earlier point of evaluating and training those models is super hard, because theoretically both responses are correct. Both answer the question is yes, you can train a model like this using XGBoost, but both are very different. Like the right one has sources to documentation, has a code snippet, and the left one is like just a text. And me as a developer, I would always prefer the right one. It's like way easier to get started. I can look up the documentation. I can like maybe copy the code snippet and already try it. And that's where RLHF can really help us. So we can really try to shift our model towards the most preferred output by humans. Of course, that can be different in terms of like what output you expect. Maybe we had like the bullet points or non-bullet points. But by using RLHF, we can really try to force the model in like a certain direction, how it should generate responses. And for this, we need this comparison data. So you have seen in the screenshot before, it's like we have like 2 different examples where we need to say, okay, what's better? There are like different techniques where you have not 2, you have more different examples which you score. So on the right side, we again have our story about Boston with 3 different examples. We could rank those and say, okay, that's like the best story I want, and the other ones are equally good or like less good. And then we can teach the model, okay, what's the most preferred output, and like try to learn to generate this. And we have like the either those different like ranking scores or pairwise comparison data, as we had from Stack Overflow, which is also now the most common way we see in like the open community being used, since it's like way easier to only get like 2 responses for something and compare, okay, is like answer A better or answer B better. And why are we going to do all of this? To put some numbers behind it, we have on the left side the ELO score from Anthropic, which also for their Claude model used RLHF to see, okay, can we improve the helpfulness of our model? And with helpfulness, they refer to like responses which are more helpful for like the human. So if we stick with our code example, for me, the more helpful answer would be to have like a code snippet inside of it. And on the right side, we have from the original Instruct GPT paper from OpenAI, a similar test where they compared the PPO is the RLHF line here, the yellow one, to SFT, which stands for like the Supervised Fine-Tuning method. And in both papers, we can see, okay, by applying those techniques, we are able to help the model force in like to a certain space where it generates more likely outputs that are preferred by us humans. Of course, doing this is not super easy, since for PPO you need like an additional reward model with more data and like a complex infrastructure, since you need to have like multiple models in like memory, and only like a few labs can use it in like a very robust and stable way. Luckily for us, I would say GPU poor people, they are alternatives. So once we have constitutional AI, which is similar to reinforcement learning from human feedback, but instead of using humans who compare the data and say, okay, left one is better than right one, we use AI, which is now a common pattern, I would say, for most of the comparison data we see in the open source space, where we, for example, use GPT-4, have like 2 outputs from like Llama and a different model, and then like try to ask, okay, GPT-4, which of those examples is better. And there we have seen that GPT-4's preferences is like roughly equal to 80-90% of like a human preference. So we can substitute AI, humans with AI. And an alternative to PPO, which is the method used by Anthropic, and also like I think correctly read in the Gamma paper yesterday for Google. And OpenAI is the alternative is DPO, which stands for direct preference optimization, which is a way easier method where you directly train on the comparison data. So you need one less step for your RLHF pipeline. And a good example is the Sapphire model from Hugging Face. The team at Hugging Face trained a Mistral model using DPO on a comparison chat data set. They completely open sourced all of the code on how to train it. So if you're interested in like what DPO is, that's definitely a great starter point. DPO is cheaper than PPO since we don't need to train an additional model to do like the ranking, and we can use pairwise comparison data. And if you want to get started with DPO, similar to SFT or like normal fine tuning, we have a trainer in TRL, which is the DPO trainer, where you, similar to SFT, need to create your data set. For DPO, we need like this pairwise comparison data set, and the rest is pretty much similar to what you know from like using transformers, so like super straightforward. And also, as of this week, similar to the guide for instruction fine-tuning, I created a guide for DPO, which walks you through end to end. Okay, what is important to take in mind? How do I need to create my data set? How can I like use TRL? What do I need to do to load my data set until training the model? And there we use a Mistral model and apply DPO. And at the end, we evaluate it. And the result is that the responses from our DPO model are more likely preferred than the SFT model, which is a great example showing, okay, we can see that it really helps improving aligning or like moving the model in like the more preferred domain there. Thanks for listening. I hope you have some questions we can answer now.
Oh, yeah. Dude, excellent. Thank you so much. So there's a few questions coming through, and we'll give it a minute because it takes a little bit of time for people to ask their questions and the stream to get to the platform. But I think one question that I saw come through, and there was an answer in the chat, but it's also cool to get your opinion on it. Like, are you using any GUIs for RLHF training?
For training itself, or for like creating this comparison data and like looking into the data, okay, like that's the better answer, or is that the better answer?
Either, I would say.
I think
Because,
like for training, I'm not sure why you would need a GUI. I think what's definitely helpful if you have like those kind of like monitoring tools like weights and biases or TensorBoard, where you can see the performance of your training. And for like DPO, you really want to look at the reward margin metrics, which is basically telling you, okay, is the model learning to correctly generate the more accepted one? And for the like data preparation method, I think there are like multiple ones. With Agila is one, which is pretty popular in the open community. And then of course you can like just use the Jupyter notebook and or Gradio, where you like iterate through your data sample and look at it manually.
excellent. So we've got a few more questions that come through the chat now. So when you're creating synthetic data, how can you ensure that the data is good or useful?
That's a very good question, I think, and it's still a bit unsolved. And currently, the best synthetic data generator are probably the most experts there. But a good way is always, like, I think that will never go away in machine learning, is you need to look at your data. So yes, you can use LLMs and AI to generate data, but you always need to like look at it and like see, okay, how does it look? Is it what I need? But of course, you can also use LLMs and AI to validate your data. So it's like very interesting, since you can use it to generate new data, and then you can prompt LLMs with some kind of criteria. What is a good data example for you, to look at all of your examples? So if you can create some kind of like constitution or like a scoring board, okay, please rate those input and output based on those criteria. Like, okay, the question should be complex and about math. And that could be a way for you to filter out, okay, that's not a math question, that may be something about like, I don't know, like art. That can be definitely used. And then of course, like what makes good data, we had it in like our instruction data set section, is I need a diverse set of data. And that's where using AI or synthetic data is really, you really need to look at it, because when we are using those techniques, we generate a lot of data, like thousands, 100,000 of different samples. And there we need to make sure at the end that we have like equally big sections for like different domains, not that we end up with like 990,000 like examples on like world knowledge, and I want to do something with like physics.
Yeah, that's not going to be very useful. That's a good call. This is an interesting one. What are challenges with RLAIF?
So RLAIF, or like which uses AI feedback instead of human feedback, more or less also fits like in this synthetic data generation type. So I need to really make sure that my feedback I use like for the comparison data is what I really expect and want it to be. And then it really depends on where I apply RLAIF. So what Anthropic did with constitutional AI, they really replaced the human feedback from RLHF and PPO with AI feedback. So they trained a reward model on the synthetic data and then used this reward model to like rank the regular LLM outputs. But what we see on like the open community recently is that we use the AI feedback for like this BPO data sets where we have like a good example and a bad example, and then directly train it using DPO, which is definitely way easier to get started and where we see really, really good results.
Okay, so another cool one here coming from Brett. Red teaming adversarial testing is becoming a popular topic of discussion. It seems that most of these talks are human powered and not most of these tasks, not talks. You can see where my head's at. Most of these tasks are human powered and not automated. What are some automated tools for assessing safety, security, accuracy, and quality that could be built or are in use today?
Yeah, that's a very good question. So it really depends on your use case. So if you are creating a public facing application like ChatGPT or others, like safety and ethics and making sure no harmful content is created is very important. But if you are working in company environment, the situation might be different. Like a good starting point, of course, is like the Hugging Face Hub. We have an ethics team which creates spaces and content and library on how you can detect biases in data set. And another good way would be using AI again for it. So Meta published a model called Llama Guard, which can help you classify and identify harmful inputs and outputs. So that you basically try to add some kind of pre and post processing in between. But yeah, I think he correctly mentioned it, that red teaming is very important. Since their humans look at the data and like what the model generates. Of course, you can like support it through AI to like making more productive, but at the end I still think we need like really experts looking at those topics to like help us classify, okay, what do we want to achieve.
Have you used the self-play fine-tuning technique? If yes, what is your take on it and does it overfit the LLM?
That's a super great question. So for the ones of you who don't know, like I think the method refers to spin, where you more or less create this the data set with like the accepted and chosen one, the comparison data set using the model by iteratively training. So you have like a good example, you have an LLM, you generate results for your prompt, then you have like a bad example from like the model, and then you train it again, and then like basically repeat the step to slowly improve the model. Currently at Hugging Face, we are working on an integration into TRL that you can like train and test it yourself, since it looks very promising from like the paper, but we haven't like run experiments. So if you stay tuned for like I would say 2 to 4 weeks and follow like the TRL team on like Twitter, you will definitely see some experiments and if it is a very alternative method.
And I think this will be the last one for you. This has been, well, okay, maybe one more if we can squeeze it in, because we've got another awesome talk coming up. But can the LLM be trained to output a decision tree? Can Wizard LM do? Does that make sense to you?
Yeah, I think kind of. So like what we have seen with like the Wizard LM, like decision tree on the right side, that was more a visualization on how you get from like your initial prompt to like those different alternative prompts. So that's not like one output. That's like you use the initial prompt an LLM to generate a new prompt, and there are like different ways you can like go to, like deepening, like changing topic or something. For outputting a decision tree, if it refers to like some kind of chain of thought prompting where you try to tell the model that it should really explain more or less how it got to the answer, which I guess is some kind of decision tree, then it's probably the method there. And there's also something called tree of thought prompting, where you use different LLM outputs to create some kind of decision tree to end up with like a better generation. So maybe that's what you are looking for. So like can try to look up like tree of thought. It's somewhat similar to chain of thought prompting, but different.
So last one for you is, in your opinion, DPO better than PERFT, PEFT?
So PFT and DPO are like not really the same thing. So parameter efficient fine-tuning helps you to fine-tune models using less compute and memory. So with PEFT, we only tune a few parameter in the model, and you can use DPO and PEFT together. So you can like use DPO to align your model using PEFT, where you only fine-tune a few parameter inside your model, and then needing less memory. So like the blog post I had on the slide, if you like look it up in like Google search, you should find it like DPO in 2024 with like Hugging Face. You will see how to use PEFT together with DPO to align a Mistral model.
Which kind of, it just dovetails into this other question someone's asking, and it's explaining the main differences between model alignment and fine tuning.
I think that's like, no, I can like totally understand why this question comes up. So it's super hard, because at the end we are fine-tuning, aligning models. Pre-training is also more or less a fine-tuning methods on just bigger data. And with aligning, we mostly, or like the research community mostly refers to like teaching certain behavior, or like using reinforcement learning, since we are not really having this input output structure. It's more that we are trying to move the model in like in a certain space. And aligning, when we think back to ChatGPT and those closed models, is to make sure that we generate not harmful content and focus on more harmless and more helpful content. And there we try to align the model to be less harmful, which kind of probably makes sense from this point of view. But those techniques can also be used for just making the model more helpful, or trying to inject some kind of like behavior on like, okay, I always want to generate code in my outputs, more or less.
Excellent. Dude, this has been fascinating. There's a lot more questions coming through in the chat, but I'm going to ask everyone to hit up Philipp on social media. The man is a popular dude. You can follow him on Twitter or LinkedIn and get all kinds of goodness every day like I do. Philipp, thanks so much for coming on here and doing this, man. This was an absolute pleasure.
Great. Have a nice day.